I'm here at Devoxx Belgium with Stuart Marks. Stuart, for those very few who don't know you yet, why don't you introduce yourself?
Okay, I'm Stuart Marks. I'm the project lead of the core libraries team at Oracle. I work on OpenGDK. I'm the maintainer of the collections framework. I look after a lot of other stuff going on in the libraries. I'm also Dr. Deprecator.
Yes.
And so I've done some deprecation in my time, and there's a lot of deprecation going on.
Okay.
A whole lot of deprecation going on.
A whole lot of okay. Yeah. But you're here, despite the outfit, you're here today as Stuart. Gonna talk to us.
I don't know. I switch back and forth at a moment's notice.
You need like a literal hat, so you can put the hat on.
No, it's a stethoscope. When I'm talking about collections, take the stethoscope on and off.
I like that. That's good. Okay, but we're not going to talk about deprecation, at least not initially. Because you gave a deep dive, Escape from the Plane of Collections, 3 hours yesterday.
Yeah.
I couldn't be there. One of the topics that caught my eye when I looked over the abstract was there was a mention of persistent collections. Mm-hmm. Why don't you give us a brief intro and then your thoughts on this and where this might be going?
Yeah, so we actually didn't cover persistent collections very much in the deep dive, although you're right, it was mentioned in the abstract. I mean, I think we just sort of in the editorial process. We did mention it, but we didn't cover it.
Don't tell me you're doing the abstract before you're doing the slides, are you? Unbelievable.
No.
Okay, yeah.
Yeah, but persistent collections, we're not actively working on it, but we're thinking about it. So we think about stuff a lot. And for instance,
what is it though?
Sure. Okay. So I think the easiest way to think about it is to compare it to the conventional collections, right? So way back in GDK 1.2, we have list, set, and map, conventional collections. You can create one and you can add elements, you can remove elements, you can, like in a list, you can set something, you're replacing a previous element. So they are mutable.
Yeah.
Okay, so you create a collection, you add stuff into it, you mutate the collection. And that's the way that a lot of people write Java programs.
Yeah.
Okay, so in Java 9, actually there were unmodifiable wrappers already, but in Java 9, I introduced list.of, set.of, map.of, and a few other APIs that provide unmodified. Yeah. Okay, good, glad you like them. Thank you. They are unmodifiable collections.
Yeah.
So they're basically the same list, map, and set. It's just that the mutator methods are blocked.
Yeah.
And so if you try to add, it just throws unsupported operation exception. Okay. So it's great if you have a bunch of stuff, you set up a collection, and then you never want to change it. There actually are a bunch of applications for that.
Yeah. That's what I love them, right? Because there are often cases where you know what the elements will be, and then you're just sure that you want to push them maybe downstream. Nobody's supposed to change them, so that you can share them across threads.
Yeah, exactly. Okay, so now what happens is sometimes you have an unmodified collection, and it's like, well, I want the same collection of elements, but I just want to add something else.
Yeah.
How do you deal with that? Well, okay, you basically have to copy them all into a new collection while adding another one.
Yeah,
and that's really expensive.
Yes.
Right?
I've done that also.
Yeah. And actually, I think it might have been you. It's can you have an API that just adds one method and returns a new collection?
Yeah, please.
Yeah. Well, so
I
think though, so it's tempting. But I also kind of think it would be a wrong idea because if you have an array list, you say list.add, it just adds it to the end. If you have list.of and you say add, it creates an entire copy and then adds it. Right. Yeah. So now we have add one element could be fantastically expensive. Yeah. And so we kind of don't like APIs that have these wildly different performance characteristics.
Yeah, that makes sense.
Yeah. So what you really want to do is have something that combines immutability and the ability to change things. It's like, how is that possible? You can't change something if it remains immutable. But what you can do is you can have something that remains immutable, and if you want to change something, you produce a new edition of it.
Yeah.
And so that's what persistent collections are.
But not a copy, right? You basically pointing to the old one.
Okay, so conceptually, So conceptually, if you take an old collection and suppose you have a persistent collection and you add an element, conceptually you get a completely new collection.
Yeah.
Now, ideally, you would have a bunch of sharing between the old one and the new one. And so but the point, the persistent comes from the idea that once you've created such a collection and you add something to it, you get a different collection, but the old one remains the same. It persists.
Yes.
So it's not persistent in the sense of JPA or hybrid.
No database involved.
Yeah, exactly. So it's persistent in that once you set up a data structure, it never changes. So it really is immutable. But then when you make modifications to it, you create new additions. So if you do add, you're creating new collections all the time. And so the challenge of those is to have a smart data structure that shares a lot of the old stuff while providing the illusion that, oh, you've created a brand new collection without making an entire copy.
And that would then have more predictable performance characteristics.
Not necessarily.
Oh, not necessarily.
Oh, yeah. So this is
so
maybe. So the add operation would, but the thing is, okay. So one of the issues is that with persistent collections, so since you're constantly building up the data structure incrementally, and what happens is if you have a lot of additions, removals, and changes and whatnot, then you have all these little objects spread all over memory.
Mm-hmm.
And so then if you want to say, oh, okay, I want to take all of those and visit each one, now you're bouncing all over memory.
Yeah.
Okay, so that's another challenge, which is, so there's a lot of research been done on this, which is cache-friendly persistent collection.
Yeah, because that what you just described doesn't even really show up in like the Landau symbol kind of analysis, right? Like that you jump around memory is not something that usually the O of n and O of n squared kind of things track, right? That's just, that's a real life problem that theory will not necessarily catch.
Right. Yeah, so there's a lot of issues going on. I think the biggest issue is what API should it be? And I think we do not want to take the existing collections API and try to graft persistent collections into it. Because there's so much of the existing API is around mutation.
Yeah.
And so, well, you could take the non-mutation portion of the existing API, and maybe it would be nice to have some similarities. But one of the problems is that there's a lot of mutation everywhere, right? So iterator. Yeah. You can get an iterator. Oh, then what could be simpler? You just want to iterate the elements. Well, iterator has a remove method.
Yeah, good point.
So, okay, and so I think
it's actually like specifically list iterators remove method is like really, really valuable because that's like the best way to safely remove while iterating, right? I mean, we now have remove if that can probably catch similar cases. Yeah. But still, like before that was like the best way to remove elements.
Yeah, in the early days, it was the only way to remove things. During iteration, exactly. Yeah. So I think okay. So that's there's a bunch of dynamics going on here, right? So there's just a different programming model. We want a different API. There's some memory. What did I say? Not memory latency. Locality. Memory locality issues. And then I remember I was thinking of another issue and then I forgot it.
Okay. We got enough issues.
Yeah.
Though,
okay.
So
all right. Well, there's a lot of stuff going on.
Thinking about this, and this is not straightforward. Other languages do have it. So some of those struggles are like just in the domain of persistent collections, and some of those struggles are Java specific, like how to express that in the Java API, right? That's some of the specific. Okay.
Right. Actually, I remember the other issue, which is Valhalla provides us potentially a bunch of new techniques for dealing with data structures. So maybe you can come out with something, and then when Valhalla comes along, we could retrofit it. Or there are actually a lot of things that are starting to queue up behind Valhalla, like the vector stuff, right? It's in its 9th preview now, or something like that. I've kind of lost count.
The jet still counts up, but it's ridiculous.
But
we should have a birthday when it's 10th. It might be 10th or 24.
So. Yeah. Well, if when it gets to drinking age, you got to watch out about that. But the point is,
Germany's getting close.
Yeah. Oh, right. Okay. So the issue is, you have an API, and it seems like the model is correct, but there are too many things that require the creation of separate objects on the heap.
Yeah.
And so they need to wait until Valhalla gives us value objects and then adjust the API to use value objects. Yeah. And I don't know what the impact of that will be on collections frameworks. Yeah. Right. So
it makes sense not to do something now. Like this is a vector API. They're pretty sure they're done for now, but they don't want to then be like, oh man, if only we had waited.
Exactly. Exactly.
Okay, so we don't want to put any more pressure on Brian, but Brian is watching.
There's a
there's already a lot. Yeah, we don't want to add to it. Okay, so that closed the persistent collection part.
Okay.
By the way, if people have questions, do put them
you're looking into the chat here?
Yeah, I'm looking at the chat at the same time. So if you have questions to Stuart about this or any other collection-related topic, maybe even Dr. Deprecator, you can switch gears really quickly. So if you got any questions there. But so what did you talk about then?
Okay, well, we talked about a whole bunch of things, but one of the things that's been cooking for a long time is this idea of of set membership. Well, who cares about sets? I mean, you use sets, great, but what do you mean? What's the issue with set membership? Well, so there's this idea, and if you've watched any of my old talks and stuff, I've been developing this idea for a long time.
But I've talked about this actually last year when we asked you some questions, because I think equals, because this is about equals and,
so there's a bunch of issues intertwined, but one of them is some collections are sorted, and you provided a comparator or comparison method, and the comparison method is used for arranging the elements in order. Okay, that's good. Well, it's also very subtle, but the comparison method also is used to determine which things are duplicates. Mm-hmm. So our classic example is a tree set. So you throw a bunch of strings into a tree set. Okay, it puts them in alphabetical order. Okay, and that works fine. Now it turns out that string is comparable, and so comparable is a comparison method that's built into string, and that is consistent with equals.
Yeah.
And so
what does it mean, consistent with equals?
Okay, so a comparison method returns an int, and it's really wanting to return one of three values. A negative value, a positive value, or 0. Mm-hmm. And what that means is, if it returns a negative, okay, so basically you hand a comparison method two values, and the job is to compare them in an ordering sense. Yeah. Is the first one less than, greater than, or equal to the second one? Okay, and so the comparison method's return value of negative, positive, or 0 are what the return value indicates which of those it is. Yeah. Okay, now suppose you have a comparison method that you give it two values and it returns 0. So you say compare AB and the return value is 0. Okay, so what if you said A dot equals B? Does that return true or false? Well, gee, you compared it and it returns 0. That meant it equals, right? So therefore, A dot equals B should be true. Yeah. Not necessarily.
Right.
So here's a weird thing.
Case, like something integer that makes sense, right? Yeah. Two integer 5, they're comparable. The comparator would say 0, and also they are equal.
Yeah.
But you're saying there are cases where that is not the case.
That's right. There are some.
Sounds fun.
Yeah. So it's okay. So the root of this is if you read the specs actually talk about this issue. And there's this long-standing bug, which is we need to clean up the specs. The problem is we haven't quite figured out what to say about it. So the specification for comparator and comparable says something about a comparable should be consistent with equals. If it's not, it's actually okay, but it will behave strangely. And it's like, oh, come on, give me a break, right? So actually, how this all started was I wanted to dig into that and figure out what the real issue is. So anyway, okay, so let's talk about the real issue, which is you have a comparison method, you feed it two values and it returns 0, and so that should mean that A dot equals B is true, right? And it is for certain things, but it's not for other things. It's like, well, that must be really weird. Sorry. If the comparison method returns 0 in exactly the same circumstances that equals returns true, that's what it means to be consistent with equals. Makes sense, yeah. You have a comparison method is consistent with equals means that those are in alignment. Yeah. But there's a possibility that the comparison method, when you give it two values and it returns 0, might not do so in the same circumstances as equals returns true.
And immediately I can see two error cases, right? One of them is it says 0, but equals says false. But it could also be the other way around, right? Equals says true, but it says no, one of them is not true. Yeah.
So it turns out that both of those exist, but the usual one is that the equality, the equivalent relationship for comparison is usually broader than equals. And so it's like
there are more zeros than truths.
Well, yeah. So I think to develop an intuition, I think it's easier to talk about an example. Yeah. Because it's like it must be weird. It's like if two things compare and the result is 0, why would that ever not be equals? Okay, so have you ever wanted to do a string comparison in a case-insensitive fashion? Yeah. Seems pretty useful, right? Yeah. Oh yeah, sort these strings, but ignore case when you're sorting them. Yeah. Okay, so there's actually a comparator built into the JDK called string.case-insensitive order. I think, something like that.
I didn't know that.
Yeah. Okay.
Nice.
Yeah, it's right there in the API, and that's true. So if you have a bunch of strings, you'd say list.sort string.case insensitive. It sorts them in a case insensitive fashion.
Yeah.
But what that means is if you have a capital A and a lowercase a, well, it's case insensitive, right? So those are actually equivalent.
Yeah.
So if you say capital A compared, string.case insensitive order. So so if you take that comparator and you say compare capital A and lowercase a, it actually returns 0.
As it should,
As
right?
it should, because you want it to be case insensitive, right? On the other hand, if you say capital A dot equals lowercase a, it says false, of course, because they're not equal.
Yeah.
Okay, so here's the problem, which is that if you create a tree set and you use case insensitive order, then its notion of a duplicate includes an uppercase a and a lowercase a. So we actually demonstrated this in the deep dive yesterday.
Okay.
Yeah.
So the tree set considers those equal. Because the comparator says 0.
That's why I said equivalent.
Duplicate. You said duplicate, right?
Or duplicate or equivalent. Yeah.
Yeah, but the contract of set is written in terms of equals.
Exactly, and that's the problem.
Yeah.
Okay. So we have to fix the specs. Sorry, we have to fix the specs because the spec contradicts itself.
Okay.
But there's this question of what the specs should say.
Right.
And so one of the things is we've over the past I guess a few months ago now, we brought Kevin Berillian on board to the core libraries team. So Kevin is the former project lead of the Guava open source Google library, and he has done a lot of thinking about library stuff. And
he's seen so many use cases.
Yeah.
For this. Like it's really broad.
So he has a lot of experience dealing with a lot of code.
Yeah.
And so I've been spending a lot of time talking to him about this. Spent a lot of time talking to a lot of people, and I've learned a lot. But I've spent hours with him talking about this kind of issue as well, and it's really important because his experience from maintaining a library and looking at code that uses the library is if you take a set and you install a comparator that is inconsistent with equals, and then you spread it around and mix it with other sets like hash set that are consistent with equals, you get bugs. You get really weird, hard to.
It's always a mix. What means like they all run around under the set interface,
right?
So users don't know that this is equals ignoring set basically.
Right. So basically, you get these weird things where, I have this set. I got this set from somewhere, and I call contains on it, and it behaves exactly. I got this other set from somewhere else, and I call contains on it. It's like, why am I getting this different behavior?
Yeah.
Right. And so if you mix those, or if you can actually compare sets using equals, or you can say, take one set and remove all from another set. You can do set intersection and union operations and stuff like that. And if you mix sets with these different notions, okay, so the idea is you have object.equals determines, well, so basically what this ends up in is set membership.
Yeah.
Right? So the idea is that for something like a hash set, it can't have any duplicates, where a duplicate is two things where equals is true. Yeah. Okay. Tree set is actually different. It says it can't have any duplicates where the two things compare to 0.
Yeah.
Okay. And there's actually another one, which is identity hash map.
True.
Which is it can't have two things where they are equal to each other.
Yeah.
Right.
The same.
So the problem is that there are different kinds of sets floating around in the JDK. The implementations are there, and we have to deal with them. And if you mix them together, you get these weird effects.
Yeah.
And so set really kind of does want to be based on equals, because that makes the most sense, because every object has equals on it. At the same time, there are these other sets which have some uses that potentially, the identity hash map, that's really useful for certain things. There are other use cases for having a tree set or tree map with a.
They don't exist for no reason. They're there because they. hash set is clearly. I'm saying clearly. I don't know how clear that actually is, but my impression is that hash set is 80% of sets probably. But that doesn't mean that
probably higher actually.
Yeah, that doesn't mean that those other ones are not really important, right? They still do valid important things. Identity hash map specifically can be really, really helpful. And essential actually.
Yeah.
Okay.
Right.
Can I get to an audience question?
Sure.
Okay, so let's see what we got. Why did sequence collections implement features from sorted collections? Since these functions are only used in sorted collections. I'd love to know why that happened. Why did sequence collections implement features from sorted collections?
Features from sorted collections.
Oh, wait, it says, oh no, wait, it goes on. Never mind, the reverse is actually true, where sorted collections have functions from sequence collections that don't make sense for them.
Ah, okay.
Yeah.
Okay.
So
yeah.
like at first, for example.
Right. Yeah. Okay. So that's a design compromise.
Yeah.
Okay. So
it's like Java's tagline. Java, 25 years later, it's a design.
Yeah.
There's so much
okay,
existing
so
things.
I'm convinced that any sufficiently complex system
Yeah.
will have places where it will have inconsistencies. And
of
the
course,
art.
Yeah, I didn't want to like downplay that
Yeah.
thing. Like it's just natural. Like if you have something complex and you like, it probably already has inconsistencies. It's actually arguably proven by math actually about indecipherability.
There's like Gödel's incompleteness theorem.
But then also if you add something like it's barely ever, and every software developer knows that it's just fitting in neatly and everything is fine. Now we'll always budge against one or the other abstraction. Like we have to make a compromise somewhere.
Yeah.
So I didn't want this is not specific to Java. It's just Java has been enough.
Yeah.
It has seen a lot of that, and still continue development.
So it's interesting because actually I think that's where Java's value comes from.
Yeah.
So first of all, you can there are different ways to build big systems, and I'm familiar, and I've actually worked on a bunch of different systems over the years. And if you want to make a system that does not have any design inconsistencies, and you want it to be sufficiently complex to be useful, you basically have to build the whole thing at once.
Yeah. And
you can never deliver it until it's finished.
Yeah.
And if you have a software project that I mean I'm familiar with some software projects where they designed something and they said, oh, okay, no, this is inconsistent here. We need to change this. And they never stopped doing that. It went on for years and years and years. Yeah. They never delivered it.
They call that the Gödel loop because they don't know that they never find that state that they're hunting for.
Yeah. So that path quite often leads to failure.
Yeah.
Okay. So another way to build up a complicated system is incrementally.
Yeah.
Okay. So you can build something, then build more stuff on it, and build more stuff on it. And then you might get to some things where it's like, oh, if we introduce this thing, we really want to do this, but it would create an inconsistency here. Well, we'll change this old stuff in order to match the new thing.
Yeah.
Well, now you've broken all your existing users. And there have been other systems that have done that and have hurt themselves.
Mm-hmm.
Okay. So you can be successful at doing that, but it's really dangerous. Because if you break your existing user base too often, then some of them don't come back.
Yeah.
Okay. So what
arguably worse is the ecosystem just accepts that breakage is normal, and then everything JavaScript. Like, everybody knows there's like a deep JavaScript dependency tree that updates are harrowing.
Oh, really? You were thinking of Java? You were thinking of JavaScript? I was thinking of Scala.
Okay. So we all got our pet peeves here.
Yeah.
Pet language. But it's true. Like that's like I know specifically because for me the JavaScript project that I work with, I don't touch them too often. So when I come back after like a couple of weeks, it's like, do I want to do the updates now? I don't have like the whole day.
Yeah, exactly.
And with Java, it's not like this doesn't exist, but it's less so. And I think it's mostly a state of mind. Like the Java ecosystem is just more focused on preventing that. Yeah. And so that means that if starting with the JDK, everybody focuses on that, and then we live with arguably more consistencies. Yeah. But that means that then downstream users are also more conscious of that. And overall, there's no technical reason why Java would be less breaking than JavaScript projects. It's just that the Java community has more of a focus on, starting with the OpenJDK down or up, depending on the tree.
Yeah. Okay. So I will get back to the question, but I want to finish the thought. Right.
Yeah, okay.
So that's right. So we talked about building a big system and never delivering it until it's complete and consistent. It might take you years or it might take you forever. Building a system and then breaking it ever so often when you discover inconsistencies. So Java has rejected that. Right. Yeah. So our approach is to build it incrementally. Right, we're shipping releases every 6 months where we add new features and we try them out. That's the whole preview thing. We try them out and then adjust them before we commit to keeping them in the platform for the long term. But what that means is there are a bunch of design compromises that we have to live with.
Yeah.
And one of those is an idea which is we want to unify, we want to provide interfaces that are unifying abstractions. Mm-hmm. And so what that means is, so there's this idea of lumping versus splitting. And so it's like, the classic example there is like a list It could be modifiable or it could be unmodifiable. But there's one interface that does it. And there's a whole bunch of discussion about whether, we talked about that at our deep dive yesterday too. There's a whole bunch of discussion about whether there should have been a modifiable list and an unmodifiable list separately. There's a whole bunch of things there. It was a design compromise because you now have an interface where some of the methods might throw unsupported operation exception. But we did that so that you could have just a single interface. And it turns out that's really useful because there are only a handful of interfaces and you can pass them around. And for the most part, most people read collections. And if you adjust your programming practices carefully, you just the unsupported operation exception problem just doesn't occur.
Yeah.
And anytime somebody complains about it, they're kind of doing something weird with their object design, I have to say. Okay. So anyway, but yes, there are design compromises because it's a little weird to have an interface here with a bunch of methods and it says, oh, this might throw an exception.
Yeah.
Okay.
But if you recap, just to be clear, that on the list interface, that's all the modified ones. That's everything reading is guaranteed to work, everything writing can potentially throw. That's like the summary, right?
Well, yeah, and so one of the things is, so that's true. So the so-called optional methods can throw unsupported operation exception. And if something is completely, so the only optional methods are the mutators.
Yeah.
And so for an unmodifiable collection, they all throw.
Yeah.
But there are actually some weird variations where some of them work and some of them fit.
Yeah,
exactly. There are a few, So
let's not go there.
Yeah, okay.
Let's stick to the sequence.
Right, okay.
All
right.
Sorted, yeah.
Yes, well, sequence, okay, so here's the thing. So we have list, set, and map, and we wanted to know, in sequence collections, we want to introduce this notion of a collection that has a defined encounter order.
Yep.
And so we introduced some new interfaces to do that. Sequenced collections, sequenced set, and sequenced map.
Yep. Okay.
And so if you have a collection that has an order and it's linear and consider a map to be sort of a linear collection with consisting of pairs, which are the map entries. Mm-hmm. There's a first element and a last element. And what can you do? You can do operations at the end, like getting them, adding them, or removing them.
Yeah.
Okay. And that works for most things, right? So list and deck are sequence collections. Linked hash set got enhanced to support sequence set, adding, add, remove, and get at the beginning and end. And then there's sorted set. And so the problem is the order maintained by sorted set, you don't call APIs and move elements around explicitly like you can with linked hash set. In sorted set, it depends on the values themselves. So you can't say put this element first because it doesn't make sense because sorted set has to put the element where it belongs in the sort line.
Unless you're accidentally picking the smallest element, that insert doesn't make sense.
Well, yeah, in general, it doesn't make sense. And
So what I'm saying, the question is how to handle that, and you make the decision that in general it shouldn't be possible. Yeah. But what I'm saying, inserting at the front there's very few cases where this could even technically accidentally work. So in most cases, it's just wrong to add the wrong number in the beginning.
Yeah. So one of the things about one of the things that I've tried to do in dealing with the optional methods is make it very clear for a particular instance of a collection. If it's optional, it's either going to work or it never works.
Right. So
it doesn't sometimes work.
Yeah, that makes sense.
And there actually are some things in the collections framework that sometimes work, which is a little weird because what it means, if it sometimes works, then your testing might have it work, and then in production you might get slightly different data, and then it'll blow up at runtime. So I try to avoid those, right? So yeah, you could make add on a sorted set work if it happens to be the element that naturally sorts into the first position, but that seems like a bad idea.
Also, I didn't want to advocate for that. I was just saying that just to illustrate the situation.
But it's a design alternative.
Yeah.
And I actually considered it and rejected it.
Yeah, I like the reliability. Yeah, testability is a great example.
Okay.
Yeah.
So, but anyway, so the point is we have these abstractions represented by interfaces, sequence, collection, set, and map. And where do sorted set and sorted map fit into those? Okay. So you can certainly do get on them. You can certainly do remove on them, unless it's unmodifiable, in which case it.
Yeah.
Right.
And also they match the concept of sequence, right?
Yeah.
Sorted seems to be a subset of sequence. Everything that's sorted has a sequence clearly.
Yeah. So, but it really does not make sense to try to add something at an explicit position, the first or last, for something that has has a sorting order based on the value of the thing you're adding.
Yeah.
And so what do you do about that? Well, okay, so you could create another interface, or you leave them out, or you could create another interface that says, sequenced but without add and sequence, right? And so one of the problems is, actually, here's another thing, which is naming is hard to begin with. And if you need to create a bunch of new things, then if you start naming them after their structure, you're not doing any abstraction anymore, right?
Okay.
So occasionally somebody will come along and say, well, there's this problem where this is modifiable and unmodifiable. This other thing you can remove from it, but you can't add. Or this other thing you can, like arrays.as list. You can set, but you can't add or remove.
And you say that all of that will have its own interface, like there's the abstraction.
So the extension of that is, okay, so we need a settable interface, we need an addable interface, we need a removable interface. And so now you define your entire interface hierarchy around structure, not around semantics. And one can design a system that way, and maybe one can design a system that way successfully. But that's not what we do, right? We design interfaces around abstractions. And so the abstraction of sequencing is, you have a sequence, and there's a first element, the last element, and stuff in order. And the thing that covers most but not all of the collections that have an encounter order is add, get, and remove. And so we could either try to add a few more interfaces and do some weird hierarchy matching, or we can say, a sorted set is a sequenced set, it just doesn't support add. So it throws unsupported operation exception for those. It's kind of similar to, like, you get a maps key set, you can remove but not add. So it's kind of the same design considerations. And so yes, it is an inconsistency, but the fact is that it's not necessarily just the operations you have. The fact that a sorted set can be a sequenced set from the standpoint of reading it and also processing it. The elements are in order. It's a very strong and useful abstraction. So that's why.
Yeah, that makes sense, and it fits also into the general. But if you would start splitting here, that would be weird, because those splits, the lumping versus splitting part,
right,
the other ones are lumped, and now you start splitting here, and it's also that would be another kind of inconsistency. But okay, good, Stuart. Thank you very much. I think that answered that question very thoroughly. I enjoyed this conversation as usual. We went way over time as usual. It's just so much fun talking to you about all these things. The steel cables showing their nature again.
Yes, that's right.
We're going to have, in a little bit over 6 hours, we're going to have Angelos Bimboudis here to talk about pattern matching. I hope everybody will be there then. If we end the stream in a couple seconds, then you will just stay on and you will get the screen. You can just click the notify me button there. Stuart, once again, thank you very much for being on.
Welcome.
And I see you around the conference. Have a good one.
Okay, thank you.
Bye.
Bye-bye.